Welcome to the 20th part of Spring Boot Kubernetes tutorial series. In this video, we are going to start working with Kubernetes pods and deployments. We will learn how to spin up a pod using ad hoc imperative commands, and also we will learn how to create pods using YAML Manifest files. We will also learn how to view the logs of a container and then how to connect to a container running within the pod. And finally, we will learn how to create deployments and then scale up and scale down pods as per our needs. In the previous episode, we have set up kind cluster and also installed Lens tool where we can see the details about the pods, deployments, and many other things. So now let us first run this command of kubectl get pods to see the details of any running pods. Right now there are no pods running, so it's showing no resources found in default namespace. Now usually there are two ways to create a pod. One is using ad hoc imperative commands, like you can run kubectl run, and here I have given a name to my pod and also specify which image I want to use for creating this pod, and also saying what is the port that the pod should listen on to. So this is the command we can use to create a pod. So now I am running this command and it says pod/bookmarker API created. And if you notice, in the previous episodes we have configured GitHub Actions. Whenever we commit the code to main branch, it's going to build the image and then push to Docker Hub. So here you can see we have bookmarker API, bookmarker UI Next.js, both the images published on Docker Hub. So now when I run this command, it's going to pull the image and then start the pod. So now if you run the same command of kubectl get pods, it's going to show, okay, we have one pod running and it is ready, 1 of 1, and it is in the status of running. Okay. Also, if you want to see the details here, you can see under workloads, if you go to pods, you can see bookmarker API is running. Okay. Now, as of now, we don't have the ability to directly access the bookmarker API from our host machine. So let us see the logs of that pod. What we can do, kubectl logs and bookmarker API. If you simply leave up to the pod name, it will show all the logs and then exit. But if you want to tile, you can append -f. So if you run it, so here you can see our Spring Boot API logs being displayed. So if you have any number of pods and if you want to view the logs of any particular pod, you can specify the name and you can see the log details. So here you can see our service by default, it is using H2 database, and then it ran flyway migrations and then started the application. But at the moment, we don't have ability to access these API endpoints from our host machine directly. What we can do, we can use kubectl exec command to start an interactive shell. So here we are using kubectl exec, -it means interactive terminal, and the name of the pod, and --, and what is the shell that you want to start. Here I am starting bin/sh. So now I am into the container, right? So here I will be able to access the API endpoints. So let us use the curl command, curl http localhost 8080/API/bookmarks. If you remember, this is the endpoint we have for fetching all the bookmarks using PageNext. So here, when I run this command, I can see the bookmark details being displayed on this console. Okay, this is how we can access. And let me exit this. And also, you can do the same thing through Lens tool also. So now first select this pod, and here you can see on this buttons pod logs and pod shell as well. If you click on this pod logs, you can see all the logs of that particular pod here. And also if you click on this, and here there is pod shell button. If you click on this, we will actually it executes the very same command, kubectl exec and then pod name. So right now we are inside this pod. Now we can run the exact same command, curl http localhost 8080/API/bookmarks. You can see the response. So that is how easy it is to use Lens tool. This is really helpful if you want to see more details about any parts, any deployments, things like that. So you can use kubectl get pods command to view the details of pods only. But if you want to view the details of not only pods but also deployment, replica sets, and services, instead of kubectl get pods, you can say kubectl get all. So right now there are no deployments or other services running. That's why it is displaying only our pod and also the default Kubernetes service information only. But if you have more deployments and replica sets, it will also display all of that information as well. So it's a very handy command to see what is being run in our cluster. So far we have seen how to run a pod using ad hoc command, and then we have checked the logs, and we open a shell into the pod, and then invoke the API endpoint. And finally, let us see how to view more details about a particular pod using commands like kubectl describe pods and the pod name. So it will display a lot of information about the pod. So what is the name, and which namespace it is running in, and what is the node it is running in, and a lot of information here. What are the containers running as part of this pod? So you can see a lot more information about this particular pod. And finally, how can we delete a pod? So again, kubectl delete pods and pod. So this is a common pattern that you can follow, like kubectl and what is the web like you want to get or you want to delete, and what is the object type, is it pods, deployments, and then the object name. So this is some kind of a common pattern that you see while working with the different types of objects. So now let us run kubectl delete pods, and it is going to delete the pods and then destroy any containers running as part of the pod. And now here you can see, if you run kubectl get all, now there is no pod running, only the default Kubernetes service that is running is being displayed. And here also you can see the pod got deleted. You don't see any pods running here. So that is how you can use various commands to work with pods. But this is fine to explore and learn about some basics of a pod, but usually you don't keep running this command in ad hoc manner, right? While working with the team, you want to have some kind of a manifest file that defines what is your pod and how to create it and all that using YAML based manifest files. So one thing what we can do, we can start from scratch and then write down all the manifest by hand, or there is even easier way. So earlier we have run this command of kubectl run pod name, and then what is the image and what are the ports that are we are going to export and all this, right? So in addition to that, what we can do, we can specify we want to dry run on the client side, which means it is not going to actually execute this command on the cluster. It's going to dry run on the client side only, and we can specify output the result using YAML format. Okay, so this one, it is going to just print out what is the manifest counterpart of this command that's going to be executed. It is not actually executed, so you don't see any parts created here, right? So what we can do, we will run the same command and pipe this information into pod.yaml. Okay, so if you go to our project, here we can see pod.yaml. let us do one thing. Let us create a folder called K8s and let us move this into this folder. Go to K8s folder, and now let us see what is there in this pod.yaml file. So here usually we have API version and what kind of object it is. So right now it is of type pod, and there will be some metadata and then specification of it. So first let us clean up few things which are not required. We don't need timestamp of it, and we want to name, and then we don't need status, we don't need DNS policy resources, okay, and restart policy, we don't need it, okay. And here if you see, we have labels which key as run and value as bookmarker API, but I would like it to be app. And if you want to add more labels, we can add it. We can specify version as 1.0. Okay, so this is how we can create a YAML manifest file for a pod. And then what we can do, we can, from command line, we can specify kubectl apply -f pod.yaml file. So here must number of type string. So make it as string. So now the pod got created. So it is just like the way we created from command line. We specify in the format of YAML manifest, and then we created the pod. So here again you can run kubectl get pods, and you see bookmarker API is running. You can also check from here. Okay, so again this is more convenient, like if you are working in a team, instead of running everyone ad hoc commands, you would like to have YAML based definitions, and then you can share it and commit it to your version control system, and you can see how it evolved over the time. Also, if you want to delete it, how we can do kubectl delete -f pod.yaml file. So while creation you run kubectl apply -f and then file name, and while deletion you can also run kubectl delete -f and the file name. So here it's going to check in this YAML file and then delete all the resources that are mentioned in this file. Okay, so now if you again run kubectl get pods, you see there are no pods running. Okay, so this is how we can work with pods, but in practice you don't really actually directly work with pods, because in production, right, you want always to run n instances of a pod. But if you directly work with pods, you don't have that ability to say, okay, make sure always n instances of my pod is running. You need to use one higher level object type, which is replica set. Again, replica set ensures always n instances of pod running, but you don't even directly use replica set. You would like to use deployment. Deployment under the hood uses replica set to make sure that always n instances, desired number of instances of your pod running, and also keeps track of all the rollout history, which means right now let's say you start with your application version 1.0 and you deploy it, and then it ran for a while, and then you created a new version 1.2 and you want to update your manifest files, and then you deploy your application, And this deployment keep track of what is the older version and what is the newer version, and also provide the ability to undo and go back to your previous version, or move forward and go to your newer version. So you can do all these rollout activities as well. So most of the times we don't directly use pods and replica sets. We use deployments which uses those concepts under the hood. So before creating a deployment, let us make sure that no pods are running. Okay, fine. So just like the way we created a pod using ad hoc imperative commands, we can also create a deployment using a command like kubectl create deployment bookmarker API image equals to Siva Prasad Reddy / bookmarker API. Okay, so we can create a deployment using kubectl create deployment and deployment name and specifying what is the image to use. So it responded with so and so deployment got created. Now you can run the same command kubectl get all. Now you can see there is a pod created and there is a deployment created and there is a replica set got created. So this command behind the scenes uses a replica set which internally creates a pod. Okay, now let us go here and also see. We can see in overview there is a pod and there is a deployment and then there is a replica set. Okay, you can navigate to various tabs and then you can see more details about it as well. Okay, now but again, as I mentioned, it is fine to explore using these ad hoc commands, but we want to create these deployments using YAML manifest files. So first let us delete these resources. You can follow the same pattern kubectl delete and you can specify this name, and it deleted this deployment. Not only this deployment, the other resources that got created because of this deployment will also be deleted. Now if you run get all, you see only the default Kubernetes service is running, and you can also see here all the pods, deployment and replica sets also got deleted. Okay, so how to create an YAML manifest file for the deployment? You can follow the same pattern like we have this command. Instead of running directly, we can try run on the client side and output it to YAML file and pipe it to, let's say, deployment.yaml. Okay, now we should be able to see a deployment.yaml file, and just like the way earlier we did, let us clean up a little bit. Creation timestamp, and we don't need status, this one. So let us move things around a little bit, and instead of replica. Okay, so it looks almost similar to pod, but there are a few differences. First thing is the kind is deployment, because this we are trying to create a resource of type deployment, and API version pod version is different from deployment. So you need to check what is the version you want to use, and then metadata, we have given name to it and also associated labels to this, and then we have the specification for the deployment. And under the specification there are a couple of sections. We'll talk about these a little later, but when you look at this template subsection, this is nothing but exact your pod definition. So here whatever you see, this whole thing is exactly similar to this. So this template is nothing but how do you define your pods within your container definitions, and what are the labels that you want to give for the containers running in this pod. So it is going to be looking exactly same. Once you have this template, there are replicas. By default it is running, it want to run only one template. And this section is very important, selector. So here we specified that pod template, and we have associated labels like app to bookmarker API, and the association between deployment and pods are established via this labels matching. So here the selector is matching labels, and app, the label key is app and value is bookmarker API. So how it works, let us say if I specify 2 replica set 2, what does this means is create pods of with this specification, and whatever pods that has labels app to bookmarker API will be associated with this particular deployment. So the association here is established with this matching labels. So usually you need to pay a lot of attention what kind of labels you want to give, because not only for deployment but going forward you will be using services and all. So all this association happens mostly through labels. So here for our pods we are giving the label as app to bookmarker API, and then we are associating any pod running with a label of app to bookmarker API will be considered as part of this deployment. So that's how the association exists. So now here let us keep it as replicas 1 and go back and then again see. Right now there are no deployments running, and earlier we used kubectl apply -f deployment.yaml file. So we applied the same deployment. Now we don't need to apply pod as well, because it is going to take care of running the pods that are required. So we just applied only this deployment.yaml file. Now if you inspect, there are a whole bunch of things running, and you can even see the logs. So here if you go and see the logs, the application is starting. Okay, cool. Now if you want to delete the deployment, you can do the same thing, like kubectl delete -f. Either if you want to delete directly, you can run deployment apps bookmarker API, or you can specify the deployment.yaml file. So this way it's gonna delete all the resources associated with the deployment also. Okay, so let us deploy this deployment resources, and let us wait for it to be created. So here let us see whether they are running or not. So here if you go to your pods, here you want to check the logs, you can see it is being starting the application. So what happens if I want to run not only one replica of my pod, I want to run for 2. Okay, so you can make the necessary modifications to your YAML file and then go back and run the same apply command again. First I'll apply. So what happens here, you can see it is configured, which means it's going to make sure to keep the state as we desired. So our desire is to run 2 replicas of this pod, right? So Kubernetes is going to take care of, here you can see there are now 2 pods that are running, not 1 pod. Okay, and what if I change it to 1 again? So here if I change it to 1 again and then apply the same, it is configured. And now if I go back and see, there is only 1 pod running, so it's deleting 1 extra pod that is running. Okay, so this is how Kubernetes is going to ensure that what is the desired count and what is the current reality, and then reconcile. If it needs to create more parts, it's going to create more parts. If it needs to delete existing parts, it's going to delete and figure out to delete some of the parts. Okay. Also, not only through YAML file change, you can also run command like kubectl scale replicas to 3. So you can use kubectl scale deployment and deployment name. It is bookmarker API, and you can specify what many replicas you want. So it is scaled. Now if you go here, you can see earlier one pod was running. Now it automatically spinned up couple of more pods to meet the desired capacity. So that is how you can scale up or scale down. And even there is an automated way, like you can configure based on the memory usage, CPU usage, or time based. You can automatically scale up or scale down as well. And you can also see the history, rollout history of a particular deployment. So here we can see there is only one revision we have. We just scaled up or scaled down, but let us say if we change this to something else, let's say 1.2, something like that. So then if you apply, it becomes like a newer version. But right now we don't have a newer version of this image, a different version of this image, so we are not applying it. But if you have changed some of these, it will consider as a separate revision, and you can keep track of multiple revisions like that. Okay, cool. And there are commands to see the rollout history, and you want to undo to a previous version, you can do all that as well. So so far we have seen how to create a pod and how to create a deployment and how to generate this YAML, and then we can clean up few things and how to scale up and down. So let us prepare couple of deployment manifest files for our API and also for Postgres database, because we want to use Postgres database, right? So let us prepare those YAML definition files. So here I have created two files. One is for creating a deployment for Postgres database and another one for our API. So here if we click on this, you can see just like the way we have seen earlier example, we have a deployment and we gave a name to it, and then under the spec we have a selector with app to Postgres pod, and under the template we have given the same label Postgres pod, and under the specification we have mentioned we want to use Postgres 14 Alpine, and the port is 5432. And then as part of this environment variables, we can pass what is the Postgres user, what is the Postgres password, what is the Postgres database. So if you remember, it is kind of a similar to how we did for Docker Compose setup. We are going to use this image and we specified various environment variables, what is the user credentials and what is the database name we want to use. So this is how we can specify using environment section for this pod. Okay, and there is a second file, bookmarker API YAML file. Here also we have this deployment and we gave a name, a bookmarker API deployment, and then we want to run only one replica, and also we have given this selector for matching labels of app to bookmarker API pod, and under the template we have specified the label bookmarker API pod, which is nothing but the same. And for the containers we have specified, okay, I want to use this bookmarker API image, I gave a logical name to it, and what is the container port, which is nothing but 8080. And similar to that we can pass Spring profiles active, I just want to specify that it is running in Kubernetes environment and I want to pass this profile. But right now there is no this profile specific properties file here, so it is not going to change anything. Just I wanted to use a Kubernetes profile, and later we'll enhance based on this. And also right now, if you look at the configuration, nowhere we are specifying to use this Postgres database yet, because we need to expose this as a service so that we can configure this particular part to use that service. So we haven't yet discussed how to use services. So this is for just configuring both this Postgres database and then API, and they are not talking to each other as of now. In upcoming videos, we'll see how to make this API talk to the Postgres database. So we have these two configuration YAML definition files. So how we can deploy these resources? In the same way we did earlier, kubectl apply -f, and then you can specify the file, or if you want to apply all the resources in a directory. Right now we are already in K8s directory, so the current directory, we can run it and then it's going to apply all the files in that directory. So if you go to lens, you can see here you can see there are two pods, two deployments and two replica sets. Two are nothing but one is for Postgres, one is for our application. So but still our application is not talking to the Postgres database yet. In future, once we cover how to use services, then we'll configure our bookmarker API to talk to the Postgres database. Okay, so this is how we can specify various things and then pass environment variables. So we are going to enhance these definitions as we talk on more around config maps, secrets, and then services throughout the things. Okay, and in the same way we can also deploy bookmarker UI, but we'll do it in a little later. Okay, so I hope this video helps you to understand how to work with pods and then deployments and then perform various activities like checking the logs and then stopping and deleting the resources and recreating using ad hoc commands versus manifest files. Okay, so yeah, that's it for this video, and thanks for watching and stay tuned for the upcoming videos. Bye bye.